This is how the Web API returns data after being hosted on render.com. Notice the onrender.com domain, which indicates that this is a live Web API responding to requests in real time. The API is deployed and running on render.com, making it accessible over the internet. In the previous video, we learned how to host our Web API on Azure. However, there are two main drawbacks to hosting on Azure. First, the free tier limit on Azure is much lower than the free tier limits offered by render.com. Azure provides only 60 CPU minutes per day, after which the web app is taken down for the rest of the day and resets the next day. This amounts to approximately 30 hours of uptime per month. Second, signing up for Azure requires credit card information, which, if not managed carefully, can lead to unexpected charges. On the other hand, hosting our Web API on render.com does not require a credit card. Just an email is enough to sign up. Additionally, render.com offers 750 free instance hours per workspace per month. This equals 31.25 days, which is more than enough to keep our web service running 24/7 without interruption. The only caveat with hosting on render.com is that if the web app is not actively used, meaning it does not receive requests, it will automatically spin down to conserve compute hours. If this happens, restarting the service can take a significant amount of time, usually 50 to 60 seconds, which is an unacceptably long wait time for a web API. To prevent this from happening, I'll show you how to sign up on Checkly, a service that pings our web API at regular intervals to keep it active. If our API is continuously pinged, it won't spin down. Checkly is free to use and requires only an email. No payment information is needed. By setting this up, we'll ensure that our web API runs continuously 24/7 with no downtime. Let's head over to GitHub Desktop and create a new repository by clicking File, New Repository. Give a name to the GitHub repository folder. Choose a local path. Choose Visual Studio for the Git Ignore section. Note that the repository folder with the name chosen above will be created in this local path location. Click Create Repository. Next, hit Publish Repository. We can choose to keep the code public or private. I will keep it public for my channel. Click the Publish Repository button. This adds a .gitignore file that prevents temporary files created by Visual Studio from being committed to the GitHub repository. Open Visual Studio and click on Create a New Project. Choose the ASP.NET Core Web API template and click Next. Give the project a name and specify the local path to save it. Choose the GitHub repository path we created earlier. The has placed solution and project in the same directory checkbox adds an additional subfolder where the .csproj file will be created. I prefer not to have that subfolder, so I check this checkbox. Click Next, select .NET 9 on as the framework, and make sure to check the Use Controllers checkbox. Then click Create. After the project is created, we land on the Overview page. Verify the added files. Notice that the Controllers folder contains a weather forecast controller.cease file. The convention is to use the name of the controller before the controller keyword. This name will act as a page in the URL of our API. The weather forecast controller contains an HTTP GET method named GET. Click the green button to run the project locally. A console window opens, displaying the local URL and port where the web API is listening. When navigating to the base URL, we get a 404 not found error. This is expected since no controller exists at the base location. However, if we navigate to the sub-URL corresponding to the controller name, weather forecast, we receive a response. Let's keep this functionality intact. I want to host this API and see it live before adding any additional code. Render.com does not natively support hosting a .NET project, unlike Azure, which provides native support. To host a .NET project on render.com, it must be inside a Docker container. Let's add a Dockerfile to the root of the repository. Now, let's examine the contents of this Dockerfile. The base stage starts with the official ASP.NET Core runtime, version 9.0, setting /app as the working directory and exposing port 80. This stage is used in the final image to keep it lightweight. The build stage uses the .NET SDK version 9.0, which includes tools for restoring dependencies, building, and publishing the application. It sets the working directory to /rc, copies the project file, and restores dependencies using .NET Restore. Then all source code is copied, the working directory is switched to backend project, and the project is built in release mode with output stored in /app/build. The publish stage takes the built application and runs .NET Publish, which compiles the project and outputs the necessary runtime files into /app/publish. The final stage is based on the base runtime image. It sets /app as the working directory, copies the published application files from the publish stage, and sets the entry point to .NET Backend Project.dll, which starts the application. This multi-stage build ensures that the final Docker image only contains the necessary runtime files, making it smaller and more efficient. I'll share the link to this Dockerfile in the description. Note that the structure of my root GitHub repository includes a subfolder named Backend Project, which contains the .csproj file. Let's open GitHub Desktop and commit the project template along with the Dockerfile we just added. Write a commit message, click Commit to Main, and then hit Push Origin to push the local changes to GitHub. Verify that the commit includes all the necessary files. Now let's head over to render.com, go to the render.com dashboard and click New Web Service. In the source code section, select the GitHub repository we just created. Give the web service a unique name. As mentioned earlier, render.com does not natively support the deployment of .NET projects. However, we can create a Docker container and use it to deploy our .NET API. Select Docker from the drop-down menu as the language. The GitHub branch should be set to main. For the region, select Virginia, US East, since I live in central US. Choose the region closest to your location, as this impacts the API response speed. For the remaining fields, you can leave them blank as long as the Docker file is in the root of the repository and the instructions in the Docker file clearly outline how to build the .NET project and where to find it if it's inside a subfolder. For the instance type, choose Free Instance, which provides 512 megabytes RAM and 0.1 CPU power. The remaining fields can be left blank. This setup works only if the Docker file is correctly placed in the root directory and contains proper instructions, as mentioned earlier. Click Deploy Web Service. The build process will start, and logs will display the execution of each Dockerfile instruction step by step. After a successful deployment, you'll see the message, "Your service is live." Go to the published URL and navigate to it. A 404 not found error will appear. This is expected since the sample Visual Studio project does not include a home controller. However, if we navigate to the /weather forecast sub-URL, where a controller does exist, we will receive a response from the live web API. Now, let's ensure the web service remains active and does not go down due to inactivity. Render.com automatically makes the web service inactive and spins it down after 15 minutes of inactivity. To prevent this, we'll set up a service that pings our API periodically, say every 5 minutes, before it becomes inactive. Let's head over to checklyhq.com. Select API check. Copy the web URL, including the /weather forecast sub-URL. Click Create Check. Run the request to see the response. Go to the Scheduling and Locations tab. Set the interval to 5 minutes. Choose Round Robin as the request method. Select a range of locations from which Checkly will ping our API. Since we've chosen Round Robin, the API will be pinged from different locations sequentially. Keep the other settings unchanged. Verify the URL and selected locations. Click Save Check. Go to the home page and you'll see the check being performed. We can see 2 locations from which the web API was pinged. P50 represents the time taken to receive the first 50 KB of data. In this case, it is 64 milliseconds and 67 milliseconds, respectively. If there is a problem, such as the web API going down, it will be reported here. This concludes the tutorial. We have successfully deployed our web API, ensured it stays online 24/7, and prevented render.com from making the server inactive. In the next video, we'll connect our Blazor front-end website with our ASP.NET API. We'll request data from the web API and display it on our front-end page. Later, we'll learn how to integrate a SQL database, starting locally, then moving to the cloud using Azure and supabase.com. By the end, we'll have a complete setup, a front-end client, a back-end API, and a database to retrieve and store data. If you found this tutorial helpful, consider subscribing. Let me know if you have any questions in the comments. Thanks for watching.